Jai Hind, all. My name is Shivpratap Singh, Assistant Professor, Akgec Engineering College, Ghaziabad. Today, our topic of discussion is tree. So we are discussing data structure, Unit 4, tree. In previous discussion, we already discussed what is tree and what are the types of tree and how to represent tree in logical ways. Also, we understands how to check tree. So these all are the basic discussion that we already covered. Now, today we are going to discuss different aspects of tree, how to traverse a tree, or we can say a tree traversal. What are tree traversal? Traversal means visiting. So the tree process of visiting the nodes is known as tree traversal. Visiting of the node is known as tree tables. And there are three types of traversals are used: in-order traversal, pre-order traversal, and we have a post-order traversal. So we have three types of traversal: in-order, pre-order, and post-order traversal. First discussion is pre-order traversal. The technique follows the root left right policy, root left right policy followed by pre-order traversal. It means the first root node is visited. After that, the left subtree is traversed recursively, and finally, a right subtree is recursively traversed. And as the root node is traversed before or pre the left and right subtree, understand this point. As the root node is traversed before or pre to the left and right node or left or right subtree, it is called pre-order traversal. It is called pre-order traversal. And the applications of pre-order traversals, where we implement our applications, used to create a copy of the tree, and it can also be used to get the prefix expression of an expression tree. So where we want to express or prefix expression of a expression tree, we use pre-order traversal. And these are the algorithmic steps of these two. Until all the nodes of the tree are not visited, step 1, visit the root node. We have to visit the root node, traverse the left subtree recursively, and traverse the right subtree recursively. Now, for understanding of these theory, we can have, suppose we have a tree where A is the root node, B and C are the siblings or the children of A node, and we have D and E as the children of B, and we have F and G as the children of C. Now, I want to visit this tree with pre-order traversal. So, first we have to visit root node. So, A, then we have to visit left subtree recursively. This is the A node, and the left subtree of this A is this, and the right subtree is this. So now we have to visit left subtree of A. So we are here. Again, we have B, D, and E. Again, we have to visit the root node of this subtree, B, D, E. So we have to visit B, again B. Now again, the left subtree of B, the right subtree of B, left subtree of B is D. So we have to visit D. D recursively, left children, null, right children, null, recursively back to the parent B, left subtree is fully visited. Now the turn for the right subtree. So we will visit E and again check children of E. So there is no children of E. Left subtree and right subtree both are blank. So we again revisit or recursively go to the parent of B, then the B left subtree visited, right subtree is visited. Again recursively go back to A. So A root node, we have already visited the left subtree of A. Now we have to visit the right subtree of A. So we have to visit the right subtree, and here we have this subtree C, F, G. So in this subtree, we have to visit the root node of this subtree. So this C is the root node of this subtree. Again, left tree or left subtree of this subtree C, F. Recursively check the children of F, no children. Again, recursively move back to the C and again visit the right child of C, that is called G. So this is called pre-order traversal of a binary tree. So this is the simple example of a pre-order traversal. Simple example. So, and this is the order of the traversal: A, B, D, E, C, F, and finally we have this G. So this is the order of traversal: A, B, D, E, C, F, G. Again, we have a post-order traversal. So what is called a post-order traversal? The technique that follows the left, right, and root policy, left, right, and then the root policy. It means that the first left subtree of the root node is traversed. First left subtree traversed. After that, recursively traverse the right subtree. So first we have to traverse the left, then we have to recursively traverse the right subtree, and finally the root node is traversed. In previous discussion, we have to traverse root first, then go to the left subtrees of root, then we have to visit recursively right subtree of root. Here we have to first visit the left subtree of the root, then we have to visit the right subtree of the root, then we have to visit the root. So a recursive procedure. As a root node is traversed after or post the left and right subtree, it is called as post order traversal. And the applications of this post order traversal is used to delete the tree. It is used to delete the key. And pre-order traversal application, we have to copy the tree. And another application of this post-order traversal, it can also be used to get the postfix expression of an expression tree. So we have to get a postfix expression of expression tree with the help of this post-order traversal. And until all the root nodes, all the trees are not visited, we have to traverse the left subtree recursively, traverse the right subtree recursively, and visit the root node. Again, suppose we have same example that we previously, in the case of pre-order, we discussed. We have a tree like this. We have a tree, and we want to traverse with the help of post-order traversal, in which we have a root A, and we have a left subtree of, and we have left subtree of root, and we have a right subtree of root, and we want to traverse this tree with the help of post order traversal. So traverse the left subtree recursively, traverse the left subtree. This is the left subtree. Again, traverse the left subtree of this B, D. Again, check the left subtree of D. There is no subtree of D. Check the right subtree of D. No subtree of D. So visit the node D. So first element visited here is our D. Then move back to the root of this D, B, again visit the right subtree of B, so we have E, so we have to visit E, check for left and right subtree of E, so left pointer and right pointers are null, so this is the leaf node, so we have to stop here, and recursively the left subtree and right subtree of B are visited, so the root will be visited, so we have to visit this node B, so we have visited D, we have visited E, and we have visited B. Again recursively back to the A, the left subtree visited, now the right subtree of A to be visited. Now in the right subtree of A, we have C, F, G, again a subtree, and in this subtree we have C, F, and G. So we have to visit left subtree of this root C, so F, and next left subtree of C. Again check the recursively the left subtree and right subtree of F. So there is no left and right subtree of F. So we have to visit F. Now move back to the root of F, of parent of F. Check for the right subtree. Is there a right subtree of C? Yes, there is a right subtree of C called Z. So now we have to visit G because G doesn't have any left or right subtree. So we have visited F, G. Now we have to visit the root node of this subtree C, and all this left subtree and right subtree is visited. Now the term is for A. So this is called a post order traversal. Suppose we have I here and we want to visit this subtree. So the order will be changed. After G, we have visited F, then we have to visit G, not G. So the order will be different. In this case, the order will be different: D, E, B, F, F, sorry, F, then we have a G, left subtree, blank, right subtree, I, then we have G, then we have C, then we have A. So this is the order of the updated tree. So we can easily understand how to visit our tree with the help of post order traversal for the applications like deletion of a tree, and also to get the postfix expression of an expression tree. This is the traversal of a tree with the help of post order traversal. Now we have in order traversal. What is called a in order traversal, and this we follows the technique of left, root, right policy. We have to follow the left, root, and right policy. Left, root, right policy. It means the first left subtree is visited. After that, right root is visited. So first left, then root, then the right subtree is traversed or visited. As the root node is traversed between the left and right subtree, root node is traversed between the left and right subtree, so it is named as in order traversal. And there are some applications of in order traversal to get the BST node, binary search tree node, in increasing order. So if we will discuss in the future a binary search tree, so where in order traversal helpful for get the nodes in a BST in increasing order, and can also be used to get the prefix expression of an expression tree. So used for prefix expression of an expression tree, and we use postfix traversal to get the postfix expression of an expression tree. So applications in the case of BST, also in the case of getting prefix expression of an expression tree. And until all the trees are not visited, perform these three steps. Step 1, traverse the left subtree recursively, visit the left node and traverse the right subtree recursively. Again, the same example that we discussed in previous two examples. Suppose we have same example as discussed in the postfix and prefix expression, and we want to visit or traverse this binary tree with the help of in order traversal. So we have to visit the left subtree of A and we have to visit the right subtree of A. First, we have to visit the left subtree of A. We have B, D, E. In the case of B, D, E, we again visit the left subtree of B. So again at the point of D, again check the left and right subtree of D. So there is no left and right subtree of D. So we have to visit D. Again back to the root node of D. So the root node of D is B. So traverse the left subtree recursively. So we traverse the left subtree recursively. Now we have to visit the root node. So we have to visit the root node, that is B. After that, traverse the right subtree recursively. So traverse this right subtree. So we have to visit E, a single node, or we can say a leaf node, and doesn't contain any children's. So we have to visit E. So D, E, and B. Again, move to the root of this left subtree. So visit A as the root of this subtree. Now on to the point of this right subtree of A, we have C, F and G nodes. So we have to visit these three nodes C, F, G. So C, we have to visit the left subtree of C. So we can say F here, a left subtree of C. Root of F, we have C as the root node of F. Now visit the right subtree. So in this case, right, we have a single node or we can have a leaf node. So we have visited G. So we have visited all these 7 nodes here, 1, 2, 3, 4, 5, 6, 7 nodes here. As we discussed about the application of this in-order traversal in the case of binary search tree, suppose we have a tree like this 50, then we have 30, then we have 10, we have 40. In this case, we have 90, then we have 70, then we have 95. As I told you, the applications of in-order traversal is to get the BST node, binary search tree, where the left children's are smaller than the root node and the right children's are greater than the root node. So we have to how to get the BST node in increasing order with the help of this in-order traversal. So if I want to traverse this a binary search tree, this is a binary search tree, this is the node, smaller elements on the left side, greater elements on the right side, 30, again the root node of this subtree, smaller elements on the left side, greater element on the right side. So it's a binary search tree. And if I want to traverse this with the help of in-order traversal, so I have to first visit the left, left, left. So we are here 10, again we are 30 root, then we have to visit 40, right children of 30, then the root of this left subtree 50A. Then we have to visit this right subtree. In this we have to visit first left 70, then we have to visit the root of this 90, then we have to visit 95. So we are traversing a binary search tree with the help of in order traversal, left, root and right, and we are getting a increasing order of nodes. If the nodes are arranged in a binary search tree, so we will get a increasing order of nodes with the help of a binary search tree. We can have this.